Hi, my name is Jesse Anderson, and in this video, I'm going to show you how Apache Pulsar works with Legos. To start off with, let me explain what we're looking at so that you can visualize it as I'm going through it. Here on the left side, these blue sort of tiles, there are producers. And if you didn't already know it, Apache Pulsar is what's called a publish-subscribe system. And we have a publishers over here. We have these producers that produce into Apache Pulsar. And right here in Apache Pulsar, if you look, they're purple, and if you're very sharp-eyed, you can see that there is green under them. That's the bookkeeper side of things, which I'll explain a little bit later. And then over here we have our subscribers. These subscribers are going to receive this data. So let's go through and let me explain how data moves through a system like Apache Pulsar. So here we have our Apache Pulsar. We start with our producer. Well, the producer is going to produce on a topic, and that topic is how data flows all the way through to a system, all the way through the system. So we have our producer here, it's going to produce on a topic, and then these consumers over here on this side are going to subscribe to that topic. One thing that's unique and probably different about Pulsar from other messaging systems is the way that the data is sent out. So here when we produce data, instead of it going to one broker and then being replicated around, what happens is that we send 3 different messages. It's the same message obviously, but we're sending it 3 different times to 3 different brokers. So we have a kind of a broadcast where we say, I'm not going to wait for one to receive it, I'm going to send it to 3 all at once. So that's when, these brokers have received that, then they can send that on to the subscribers. So we have the subscribers receiving this message and being able to process it. So let me go through that once more so that you can see it again. So here we have our message. It's going to be produced by this producer. So we produce out that message and we send that 3 times at once. And then once that has been acknowledged, there are some configuration parameters to say how many of these do I want to know have received that message and acknowledged back before we move on. And that's what can be configured there. So now that we've saved it on those machines, now it can be sent on to our consumers to be processed. So here we have that processing. We're sending that on to our subscribers there. Now, one other thing that's unique or different between Pulsar and perhaps other messaging systems is partitioning. So when we have a piece of data, we can actually partition. And this is how we achieve such high scales and such high throughput with Pulsar. So instead of sending all the messages through one topic and one partition, we actually have multiple partitions. So we can imagine here we have our other pieces of data, and we could say we have chromatic and achromatic pieces of data, and that's our partition. So here we have this piece of data, and it goes into a different producer, broker. So we have that production, it goes into this broker, this broker, this broker, and then we have another piece of data be sent out. And we send that out, and we can send that same. And then all of this data, as it's being sent, gets sent on to the consumer there. And that is what's called partitioning. So as you can see, we're able to use the cluster resources more efficiently because now we're able to start using this broker's resources. Now I haven't went deeply into the consumers over here, but let me go a little bit deeper into how these consumers work. So although I have them in a stack, I'm going to separate them out so that we can start to visualize out a concept here. Now in Pulsar, there are several different what are called subscription modes. And these subscription modes are several different types. So I'm going to show you them now. There is one type that's called a failover mode. And what a failover mode means is that we're going to have, let's say, 2, maybe 3 different processes running. Just for the sake of ease, I'm just going to have 2 running there. And what we can have is we can have one of these running as a failover in a failover mode. That means is all the data is going to go to one consumer. But should that consumer go down, then this one is up and running, and we can start that up again. And that gives us a high availability. It doesn't give us a scalability because we're not scaling, we're not balancing the load across these, but it does give us this high availability so that we can know that if this machine goes down, this other one can pick up the work. So here in this example of the data, whenever data would be sent, I'm just going to grab some data here, it would flow through and all go to that machine. This machine, this in failover mode, this subscription mode, this machine does not receive any data. Now there is another mode, another subscription mode, and that is called round robin. So in round robin, what will happen is that we will have data come through our system, and it will go in more of a round robin or shared subscription mode. So this round robin means the first time this consumer will get data, next time this consumer will get data, next time this consumer will get data, then next time this consumer gets data, this consumer gets data in a round robin mode. So we have an exact balance of data and an exact balance of resources because we're using each one independently. Now for certain use cases, we need another mode, another subscription mode. And that is a mode where it's called key shared. And what key shared does is it says, we're going to always route the same key to the same consumer. And in this way, we're going to say, well, if we have green, what we could say is light green is always going to go to this consumer. And I'm just going to grab some more data, and we could say blue always goes to this consumer, so we can route through. And then we could say dark green always goes to this consumer. We can route that through. And we could say pink always goes to this one. We can route that through. And then as we keep on receiving data, it will always go to that same consumer. And that is a subscription mode called key shared. Now, one thing that is very unique in my experience of working with messaging systems is how Pulsar deals with an acknowledgement of messages. Whereas some systems use what's called a high watermark system, and Pulsar does support that. What a high watermark system says is, I have received, you commit and you acknowledge that you've received up to a certain point. I've received up to this point. I've received up to this point. That's called a cumulative acknowledgement. But there's another mode that I think is really powerful that's part of Pulsar, and that's called an individual acknowledgement. Each one of these consumers can actually individually acknowledge and say, I have received this message. So here we have this consumer, the subscriber. It could say, I've received this one, I've received this one, I didn't receive this one, or this one failed, but I have received this one. And what we can do is this message is now marked. It can be retried, it can be put into a dead letter queue, and dead letter queues are something that Pulsar does support. What a dead letter queue means is sometimes data is bad, and we need to know about it. So by having a dead letter queue, we can keep track of what is done. Now, the real beauty of Pulsar here is that on this topic, on this subscription, we actually know that this message was not acknowledged. We can say this message was bad data, so on and so forth. Now, in order to do something with acknowledgments like this, what we need to have is each one of these messages is going to have a unique ID. And this unique ID is formed of some pieces of data within Pulsar, but very interestingly, we can actually go through and uniquely identify each one of these messages. Now, there was another part that I've alluded to and touched on, and that is the difference between a broker and the bookkeeper behind it. So let me go deeper into that, and to do that, I'm going to move some things around so that it's easier to see what's happening. So here I've mentioned we have our broker. Now, what we can do is we need behind the scenes a separation of systems. In Pulsar, there's the separation between the receipt, the send and receipt of data, and the storage of data. So here, we actually can do this. So here we have our broker, and here we have our bookkeeper cluster. Now there are different ways that we can set this up. I don't want to go deeply into that. Suffice it to say, we can have them be separated, we can have them be together. There's various reasons for each way of doing it. But having this separation actually gives us some real power beneath the covers. It really allows us to do some interesting things. For example, these brokers are completely stateless. We could take out this broker process. We could expand this broker process. There's lots of different possibilities that we can do there, because this is individually scalable. This bookkeeper, this storage, is independently scalable from the actual receipt of data, which is quite nice. Some use cases don't need that one-to-one ratio. Sometimes they need a lot more storage and or receipt of data. It really depends. One other part of this that I didn't mention is how data is stored underneath the covers. Well, in Pulsar, as we receive that data, what happens is that data is going to be put into topics, as we mentioned, but from there, we actually get stored into bookkeeper. So we have our bookkeeper storage, and the way bookkeeper storage works is a little bit different than you may have seen in other technologies. What we do is we actually break this up into what are called segments. So here's a segment, for example, and then we have these other messages that come in. This can be another segment. And by using these segments, we're able to change the way we do resources, where instead of having one monolithic thing of data, we have that broken down into much smaller pieces so that we can do some other interesting things. Some of those interesting things are striping, where instead of having our data just written to, let's say, 3, what we could do is we could stripe it across 8 different bookkeeper machines and make some really efficient use of our data that way. This also gives us some really interesting parts around how do we store data? How do we deal with failures within bookkeeper? So some very interesting technology behind the scenes, and it's all proven at scale. This bookkeeper system is being used at large companies for large amounts of data. So with this, I hope that this gave you some background on how Apache Pulsar works behind the scenes and gives you a good starting point for using Pulsar in your next solution. Thank you.